Welcome back to the third lecture on financial mathematics for actuaries. Today we are going to cover two important concepts. One is present value, second one is discount rate. Before starting, let us quickly review what we have covered. We have already seen two important functions. One is amount function, which is denoted by AT. This denotes the accumulated amount up to time t starting from period A0. And we have explicitly derived many relationships. In that came one factor called I, which we called as interest rate. Then when this initial amount was 1 unit, we derived one interesting function which is called accumulation function, and for this unit rate, how the amount is getting accumulated, we defined by AT. And we have also seen what is the relation between capital AT and small at, and various other relations of this I and AT, capital A and small a. Also we saw two models, growth models for this AT. One was simple interest rate model, another one was compound interest rate model. In all these calculations that we have done related to AT, capital AT or small at, we were looking at the forward value of money, in the sense what will happen to my money in future. Today we are going to deviate and we will travel backwards in time, and that is where the notion of present value and discount rate becomes prevalent. So let's analyze it using today's roadmap. So first, the concept that we are going to talk about today is we are moving money backward in time. We also have mentioned clearly that money has a time dimension. So in time dimension, we are always respecting the time value of money. So how the money behaves if we move backwards in time, that's what we will look into in today's video. So in order to define this backward movement, we need a feature called discount factor. So we will define that feature of discount factor. Then we will look at the effective rate of discount after defining the feature of discount factor. And once we have this, then we can actually relate to our old notion of I, and we will relate the two new notions, one which is present value, another one which is discount factor, to our old known friend I, interest rate. The topics of this particular lecture are covered in Bowerman sections 1.2 and 1.5, Chan and Say sections 1.5 and 1.7. The interested listeners may refer to them for deeper understanding. So let's dive deeper into our class, and let us start with the concept of the time machine and how we are looking at the present value. Suppose these days many insurance companies are doing an ad that you have to plan your future, and in future you want to have some estimated amount which will be given to you. Then how much should you invest, right? That is where this notion of present value comes. So imagine I have a target of 1 unit at the end of period 1. Then we can ask, how much can I deposit right now in a bank to get 1 at the end of period 1? Okay, so this is the question that we are posing today. What we have done so far is, okay, now I have 100 rupees, I will invest them in a bank, and then I will think about what happens in future. What will this 100 grow to? This is called accumulation function that we have defined. So we will reverse that question and we will ask, if I want 100 later, how much should I invest today? So I hope the basis is clear now. Now we will look at this particular feature, which is, if I want 100 1 year later, how much should I invest now, as discounting. Why I am calling it discounting? it will be very clear soon. So here is the basic status quo. What we were looking at, if I start now, if I start putting money in the bank, I will earn I interest at the end of period 1, and the end period will have start multiplied by 1 plus I. Okay. Now what you are asking that if I want end to be this, how much should I start with, right? So the fairly easy algebra will say that if my end is 1, then I is the interest rate that will be earned on the current value. So I will have 1 plus I accumulated, which is our A1 according to our notation, 1 plus I accumulated, and then what should I multiply this with so that I will get this 1, correct? So the easy answer, if I know the interest rate will be, as this number cannot be 0, I can easily do this and I can solve for V. It will give me 1 plus I. Okay. So let us take one example which will make it very clear how to do it. So let us say your I is 5%, and then what you want to know is what will happen in the end, right? So so far what we have done, if I have 100, I want to have the next amount, so I will use this interest rate and I will have this to be equal to 100 into 1.05, and then that will come to 1050, sorry, 105, that will come to 105. Now you are asking a different question. Suppose I don't know how much to invest. I have the end goal in my mind, that is 100, and now I am asking you how much shall I invest in. I have something like 0.05, and then I am asking what is the value V that I should invest. This particular thing gives me the answer that my V will be equal to 100 divided by 1.05, which you can get the answer very easily from your calculator, and the answer is 95.23, right? So now you got the answer, right? So that's the beauty. So you do not need to invest 100 rupees at this moment. You just need to invest 95.23 rupees. But now the calculation got slightly messy. So now we will come to one major observation for this V, that is this present value that we are calling it as is inversely proportional to I. How will this translate to? If I have higher interest rate, I will get the lower present value. Okay. If I have lower interest rate, I will get higher present value. Okay. So this is an important understanding when you are trying to calculate that factor. So now once we have defined what is V, which is discount factor, now let us use this V to navigate between present value and future value. Okay. So we have already done this calculation. First we wanted to move t years ahead, so we have multiplied by 1 plus I raised to t. You remember this model? This was our compound interest rate model, which we have already studied. Now the question is, I want to move t years backward. What will I do? According to my formula for V was equal to 1 upon 1 plus I, right? So essentially this was the formula when I moved one period backwards. So if I move t periods backward and with same model, I will have 1 plus I raised to t. So that translates to divide by 1 plus I raised to t. Okay. So in a sense what we are saying is we are essentially multiplying by v raised to t. So we have a clear cut connection between the present value and future value, that is present value is future value into v raised to t. So this is what we are discounting with. So now once we are clear with these basics, let us see how to translate it into a pro tip of calculator for computing v. Use the calculator mentioned in the slide or use any scientific calculator. You just use how to compute the present value is very simple, which is if I have the interest rate of 5%, I will take this to be 1 plus I, that will give me 1.05, and once I have this number, which is the growth factor, so to speak, what we want is to discount it, right? So we will press 1.05 on the calculator, and then to discount it is to divide. So we will say 1 by x of that, and that will give me the discount factor, which is equal to this. I have shown you in the example which I have demonstrated. So it's 0.95238, and therefore this result you can store in your memory and then multiply it again and again as many times as you want, as you are multiplying 1 plus I raised to t, or that 1 upon 1 plus I raised to t. So that will be a quick pro suggestion for fastening your calculations. Okay. So now that we have understood how to fasten, let us explore the another variable that we are going to introduce is D, which is rate of discount rate, right? So this becomes handy if you follow this haircut analogy. For example, if you go to a bank and you say that you want 100 rupees, okay, bank will upfront pay you this money, but it will take a fee from that particular transaction, right? So that's the basic analogy. So they are basically taking away their haircut. So how they do that? It's basically you request a $100 loan, then the bank will keep 5% interest on it, on that $100, and then they will actually pay $95 to you. Why is bank doing that? Because they want to keep the interest with them. Okay. So they are taking the interest upfront, and then when you repay the loan, you are essentially paying 100 later, right? So this is the interest that the bank has taken in advance, and this interest rate is called discount rate. Okay. Okay, so let us contrast this with what we have studied earlier. Suppose I am investing 100 now, then what I will do, if I have to invest whole 100, and based on that I will get the interest, and if the interest is say 0.05, I will get 105, correct? This is how you are calculating so far. Here, when you are borrowing the money, you asked for 100, bank gave you 95, and then you are repaying 100, right? That means the bank has actually kept the interest with them, with itself. Okay. So this is the main difference when we are dealing with discount rates. The interest is taken upfront from you, and when you are investing, the interest is given at the end of the period. Okay, so that is what this contrast, this diagram will make this contrast clear. So here I am starting my investment, initial capital is A0, end capital is A1. When I want to calculate the interest rate, what we have done, suppose the interest for one period, we did A1 minus A0 and then divided by A0, right? Here when I am and this we called as I1, so this particular term we called as I1, so it became I is I1 by A0. Now look at this particular term, which is D, which we are defining now. It's same, interest is same, A1 minus A0, this will be the accumulated value, but it is divided by A1. Okay, and so this is I1 divided by A1. Now you understand the difference. So suppose this is 100, this becomes 105, this becomes 5%. But if you target for A1 to be 100, then things will change, right? So A0 was less, it was 95.23 in our example. So here is the example. So when you go to a bank, you receive 95 today, but you repay 100 in a year, right? So how do we calculate the interest? So if you are calculating the interest on it, it's basically interest amount is 5. However, if you divide it by an appropriate denominator, which is A0 at this point is 95. So 5 divided by 95, so you are actually paying 5.26% interest. If you look at the discount factor, you will look at the end capital, and 5 by 100 will give you 5%. So that's the difference between interest rate and discount factor. Now which one should be bigger? As you follow the time regime and we assume that money itself earns money by on it, that means interest earns interest. Okay, so if you follow that analogy, you always assume that the future value of money will be bigger than the current value of money. If you follow this, then what happens? The discount that you will get will always be smaller than the interest. We will make this crystal clear using algebraic derivation, but right now the intuition is very clear, since the accumulated value or the amount function A1 will always be higher than A0, and we are assuming no withdrawals in between. So the accumulation function is higher than A0, therefore the denominator D will always be larger, and therefore D should always be less than I. Okay, so now let us link this D with I based on simple formulae that we have studied. So D is nothing but I1 by A1, and what is I1? We have already seen I1 is actually A1 minus A0. Okay, so D is I1 minus A1 minus A0 upon A1. However, according to our this thing, I1, according to our earlier calculations, I1 is the interest earned over the initial capital, so it is always I times A0. Okay, therefore if you put everything into this formulation, your A1 is 1 plus I times A0. So all these things are well known to us from the previous two lectures. Now let us use them to derive the relation between D and I. Okay, so D and I, how they are connected. So first thing, you just use this I1 by A1 and you use A1 to be this, then you get the denominator, which is 1 plus I times A0, and you use I1 to be I times A0. Both A0s will get cancelled off and you get I upon 1 plus I. So this is our first relation. Discount rate is I upon 1 plus I. Okay, one more interesting thing I can show is this is also equal to 1 minus 1 upon 1 plus I. You can look at it, 1 plus I minus 1 will give me I upon 1 plus I. Do you know something like this? Have you seen this in this have you seen this term in this lecture? The answer is yes, we have seen this. And what was this term? This was V, right? So this particular term was V. Okay, so we will bring back this term V and we can derive the relation with it. So here is the relation, V is equal to 1 plus I, then 1 upon 1 plus I, then D is equal to I times 1 upon 1 plus I, and therefore it is IV. But if you go back one slide, I have derived D is equal to 1 minus V. Here I am saying D is IV, right? So we are actually proving some identities. So here is the first identity, which is D is equal to IV. What does this mean? Discount is present value of interest. Discount is present value of interest. Okay. Then this is another relation that I showed you. 1 minus D is actually 1 minus is actually equal to V. I showed you D is equal to 1 minus V. You rearrange it, you get V is equal to 1 minus D. Right? So that is what is being shown here. So D is equal to 1 minus V. So these are two crucial identities that you should always remember for computing the things fast. Okay. So this particular discussion comes up with one full circle, and this triangle is actually summarizing whatever we discussed in today's class. First, we started with this notion of V and we related it with I. So from I, we understood that if I am starting with 1 plus I as an interest for period 1, I want to get 1 as this, then how much should I invest? So this gave me V is equal to 1 upon 1 plus I. Okay, that is very clear. So that gave me this relation, connection between I and V. Then we discussed this connection with V and D, and there we analyzed that we have proved the second identity, which is 1 minus D is equal to V, or V is 1 minus V is equal to D. So these are the two identities that we discussed. For that I need an identity for D. So come to D, and we derived this identity. D is equal to I times 1 plus I using simple amount function calculations that we have seen, because we also understood defined D as I1 upon A1, and I1 was I times A0, A1 was 1 plus I times A0, and then we cancelled this A0 together, and that is how we got this D to be equal to I upon 1 plus I. From this we actually came to this identity, from this we circled to this identity, which gave me 1 minus D is equal to V, and that completes this triangle, and we know the interrelation between D, I and V. Okay. So now one quick question which we can easily solve. If you want, you can pause the video and calculate these things. I is equal to 10%. Do you know how to find D? The answer is yes. You go to this triangle, I is given to you. Can you find D? The bottom line. Just calculate it, come back. So the answer is I upon 1 plus I. So since D I was 10%, it will be 0.10 in the numerator, and 1 plus I will be 1.10. So together they will give me 0.0909. So 9.09%. Is D less than I? The answer is yes, D is less than I, because the initial capital is always smaller than the future capital. Correct? Now that we have studied all these things, we can actually master, we are actually in a position to master the algebra of I and D, and we will learn how to solve the problems for unknown time using logs, because we have to deal with exponents. And in all these cases, it is very helpful to use the rule of 72 to verify whether our answers are correct or not. That is the part of our next class. Thank you for listening. We will see you back in the next class with mastery of algebra between I, V and D. Thank you.